So let's go over glycolysis first. Oh man, now I have to learn how to read clocks. Okay. So glycolysis is just the process of breaking down sugar. So sugar is how many carbons?
Yes. 6.
6 carbons. So there's glucose. Step 1, we have 4 steps, right?
For glycolysis, yes.
Uh-huh. What's step 1 called?
ATP input.
Alright. So we're going to start with inputting 2 ATPs.
And where do those ATPs come from? Are they just like floating around?
Kind of left over from our last glycolysis cycle.
Okay.
Kind of just from your food. Your body naturally has some.
Okay.
Kind of like when you want to start a business, you have to input a little money to then make a lot of money. Same concept here. So we're going to input 2 ATPs. Okay?
Okay.
Let's put in here, right? So kind of 2 ATPs go into 2 ADPs, right?
Okay.
So what do? We take our 6 carbon sugar and we're going to put 2 phosphates on the end. 4, 5, 6. Now we have some phosphates. Does that make sense how we got the 2 P's? Because we have
Well, because you broke
triphosphate.
the ATP to ADP, right? So then the phosphates just bind to then the carbons.
Yep. Exactly what happens. Because we went from a triphosphate, so we had 2 of 3 phosphates, that makes 6. And then now we only have 2 of the diphosphates, so 4. So we put 2 here. So that's our step 1. Step 2 is called what?
Sugar cleavage.
So all we're going to do there is we're going to cleave it right down the middle. Okay. Step 3 is called what?
NADH production. What's that 2 represent? Just like
2 H's.
2 H's, which is just hydrogen, right?
Sometimes they'll put the the H2, sometimes they'll just put H. H2 would be more like specific, but they might not ask for it.
And what does the NADH do again?
Basically, this is going to be a transporter.
Okay.
So it's going to hold our electrons. It's an electron transporter. So that when we go down to, we'll do acetyl-CoA formation, Krebs cycle, then to the electron transport chain.
Okay.
These are electron transporters. And do you remember what the NADH, how many electrons they can? 3.
3.
So per NADH, that'll give you 3 ATP. What about FADH?
2.
2. So that's what's happening here, is we want to make some of those transporters. Because the more we make, the more ATP we end up with. So, to do that, that's why. So now let's only follow one of them, okay? And then we can just times everything by 2, since these are the exact same molecules. So we're going to have this one go down, and we're going to put in what to get NADH?
NAD.
Yep. NAD. And then what do we end with?
P's, the phosphates are both sides, right?
Right.
Yeah.
So what's happening here is I like to write, most people just write NAD, arrow, NADH2. It's actually NAD plus a phosphate. So we're just going to attach another guy on. Okay? And then we have what we called our payout phase, or our ATP production. Payout basically meaning this is our end result. So what do we get? We're basically just going to X out those 2 guys. How? What was the arrow for?
Oh, the ADP go into ATP, right?
Huh? ADP is gonna go to 2 ATP. So we had 2 times 2 equals 4, 2 diphosphates. And we went over here to 2 times, how many? For a triphosphate
3.
is 3. Where did we get those 2 from? These 2. Now we went from our 6 carbon molecule called glucose to our 3 carbon molecule called pyruvate. Okay? So now we'll circle everything that we kind of get from glycolysis. We get pyruvate, right? How many? Do we just get 1?
2.
Right, and how do we get 2?
Because there's the other molecule.
Yep. We have this entire one that we didn't draw this out for. So we get another. We're going to have 2 pyruvate. How many ATP do we have net?
2.
2 ATP. Because we normally would times that by 2, right? And get 4, but we have to minus
Because we used 2.
the input. So we get 2 ATP. And how many NADH?
2.
So from glycolysis, we're going to have 2 NADH, 2 ATP, and 2 pyruvate. So just with the process of glycolysis, we're going to have 2 ATP, but how many potential ATP do we have from glycolysis?
It's like 30,
Or just from
Or no.
glycolysis?
just from glycolysis.
Wait, what was the question?
So just glycolysis,
Yeah.
if we only look at this step right here, we get 2 ATP, right? But how many potential ATP do we have when we go all the way through the electron transport chain?
6 plus 2 is 8.
Wait, what are you doing? Oh, okay, I see what you're
6,
saying.
and then I added the 2
And
from
you
the
added
bottom.
2. You see how she got that?
No.
Basically, so this isn't counted in the glycolysis step, we just get 2 net. But when we bring our 2 NADH2 to the electron transport chain, per one of these, we get 3 ATP. We have 2 of them. So in the end, we'll be able to get a total of 8 ATP from glycolysis, or because of glycolysis.
But those are just potential right now because it has to go through the
Right.
ATC, right?
Mhm. So what if they asked you, how many net ATP do I get from glycolysis? What's your answer?
Just 2.
How many potential? 6 potential, and I do have 2.
Okay.
So if I was to ask you, how many potentially do I have? Or basically, how many ATP
The
come
other 2
from?
aren't potential because you do get them.
I do get them. If I was to ask you at the very end, how many ATP do I get because of glycolysis? Your answer would be 8.
So the net's just what's left over, right?
Uh-huh.
Just like at the end, you have a net, just a 2 ATP.
Right.
Okay. And then just from the NADH, because each NADH has 3 ATP.
3 ATP potentials. And you get this, you do this right here, during the electron transport chain. Does that make sense? So do you have any questions about glycolysis? Going from 6 carbon sugar to your 3? Cool, then that's it. So there's glycolysis for you.